Hey folks, today's topic is compound interest. So let me give a quick rundown of the difference between compound interest and simple interest. So simple interest, well, let's take a situation where you have $100 in the bank. And let's say we're going for 1 month, and if you're earning simple interest, we'll say that there's let's say a 10% return on investment, which means at the end of the month, you get $10. So the 10% of 100 is $10. Now, if it's a simple interest scenario, you'll go into let's say you put the money in on January 1st, you go into the bank on February 1st, and there's now how much money? You put $100 in there on January 1st. On February 1st, there's now $110. If it's simple interest, you take that $10 and pull it out of the bank, put it in your pocket, and then leave. Then you'd come back at the beginning of March and you'd have $110 because you had $100 in there, and that earns 10% interest. And then you take that $10 out. The next month you come back, 110, take the $10 out, so on and so on. Compound interest is where you leave that money in there. So I have $100. Then I'm taking that money and I'm timesing it by 110% because I get the original amount plus the extra 10%. And remember, you got to move the decimal over 2 times. So at the end of the month, you have $110. In compound interest, you leave that $10 in the bank this time. You don't take it out and put it in your pocket. So the next month, I'm going to earn 10% again, but this time I'm going to earn it on $110. So now I have $121 in the bank. So notice this month it grew by $10. This month grew by $11. That's because I have more money in the bank. And if I leave it in there, that amount of money will continue to grow more and more. This month it grew 12. This month it grew 13, 41. It grows. And the longer you leave it in, let's take it for a couple years. And what I want to talk about mostly is how it's growing. Let me find an easy one to do in my head. There we go. So this month, I left it in, and this month my money grew by $50 that month. Remember, the first month it grew by $10, and now it's growing by $50. The next month it grows by more than $50. So you get the idea. So, and the longer you leave it in, the more it'll grow. So that's compound interest, and this is the formula that we use to calculate compound interest. So I'm going to do some underlining of important phrases. So we have the final amount. So the money that you end up with in the bank, that's the letter A that we're going to use, capital letter A. Then this other word you're going to see is the word principal amount. You might prefer the word initial here. Initial amount, principal amount, beginning amount, all those mean the same thing. Now you have your final amount is dependent on how much you put in at the beginning and how much interest it earns. Now a reminder on how interest is calculated mathematically. We always make 25 is percent. Now that word percent, it's Latin. I don't know why we use the word percent. We should literally percent means out of 100 in Latin. I don't know why we even use the word percent. We should just say out of 100. Anyway, that's the way we say it. 25% really means 25 out of 100, and 25 divided by 100 is 0.25. So this is a reminder that you must turn all your percentages into decimals. You can do it the short way if you remember to move it over 2 times, or you can take whatever the percent is and divide it by 100. That would also give you that value. Compounded n times per year for a total of t years. Now I want to talk about this number of times per year thing. This is the part that I'm going to give you the formula. These you have to know what they mean. I'm not going to give these to you. So n number of times per year for how many years? Well, there's a couple phrases that you'll see that indicate a certain number of times per year. So if I want to, let's say you have your money gets compounded annually. How often is annually in 1 year? Well, once. Annual means once a year. The next would be monthly. If your money gets compounded monthly, how many times would that happen in a year? 12. Then we have weekly. Remember how many weeks there are in a year? 52. Daily. Now, usually they use 360, but for my class, I'm going to have you use 365, the actual number of days in a year. And then we also have the phrase quarterly. Quarterly means it happens 4 times in 1 year. Now, there are 2 prefixes that I can put in front of those that will change how many times they happen per year. The first one is semi. The second one is bi. So, for instance, I get paid as a teacher bi-weekly. So that means every other week I get a paycheck from Fruitport Community Schools. So bi-weekly means half as often. Ugh, yuck. Half as often. Semi means twice as often. I'm a comic book guy, and when I was a kid, Spider-Man was hugely popular, and they changed the publications from once a month to semi-monthly. That means that you would get 2 issues, or you'd have to buy 2 issues every month if you wanted to keep up. So let's say I wanted to talk about semi-annually. That would be twice number 1. Well, twice 1 is 2. Semi-monthly would be 24. Bi-monthly, though, would be 6. So hopefully that made some sense. Let's go through and do a bunch of compound interest problems where you get compounded a certain number of times per year, and then we'll go to compounded continuously. All right, so we have a $525 certificate of deposit. That just means something that you put in the bank. You give them $525. They give you a certificate that you deposited that money and it earns some interest. So we have $525 is our initial amount times, so P stands for the principal amount, and it's always 1 plus. This 1 plus is because your money is going to, in these scenarios, will always gain. So whatever you put in, if I were to distribute, I'd get $525. You'll get at least the money that you had back, plus your interest rate. Now remember, 4 1/4 really means 4.25. Now that's a percent, which we need to turn into a decimal. Either take 4.25 and divide by 100, or move the decimal point over 2 times, 0.0425. That goes in as R, my interest rate, 0.0425, divided by N. N is the number of times per year. So this gets compounded monthly. There are 12 months within the year, so that's going to get compounded 12 times. And then I didn't write it in the formula. You won't see it in the formula, but I really recommend it. Put parentheses up here. Now, if you have fancy calc, you don't have to worry about it, but I put them there just to remind myself. So whatever goes here, the number of times per year, is going to go again up here. And then T stands for the number of years, and this goes for 3 years. All right, the rest of this I'm going to use on my calc. 525 times the quantity, 1 plus. I'm going to use my fraction button because I have fancy calc. 0.0425 over 12. Close it to the, like I said, I like to use parentheses. You don't have to if you have fancy calc. And it turns out our $525 will have turned into $596 at the end of the 3 years. So $596. And let's round always to 2 decimal places when it comes to money. So that should be 26, rounded properly. And your dollar symbol goes in front of money. I don't know why I see this a lot lately. People put the dollar sign at the end. I know we say $596, but we put the dollar symbol in front. All right, let's have you pause and try to do example 2 on your own. All right, let's see how you did. So 5-year investment, $10,000 is worth how much if it earns 8 3/4? 8 3/4 is 8.75. Now that's a percent. I've got to move the decimal 2 times or divide by 100. Going to give you the same result. All right, so let's see. My initial amount is 10,000. 1 plus 0.0875 over compounded quarterly. Quarterly happens 4 times in a year. 4 times, and we're going for 5 years. Calc time. This time I'm not going to use the fanciness. Now that's legal. Your calc will do this correctly because division is higher up. Oop, I forgot a 0. Because division is higher up in the order of operations than addition, your calc will divide before it adds. I don't need extra parentheses there to the 4 times 5. If you want to just make that into 20, you could. So we get 15,000. $415.42. So like anything in mathematics, I think it's important to understand you should always be able to do the mathematics in 2 directions. In this case, I gave you everything and you needed to find the final amount. When we move down to the example 3 and example 4, I'm asking you how long it takes to get to a final amount. So at a rate of 6.35% compounded semi-weekly, we'll talk about that in a minute, takes how long to double $1,000? So this time I'm going to set up an equation because I already know the answer of the amount of money I should have. What should I have at the end if I'm trying to double 1,000? Obviously, I should have 2,000. 2,000 is equal to my initial amount, 1,000, times 1 plus my percentage is 0.0635 divided by, okay, now semi-weekly. You're going to have to memorize this. I'm not going to give this to you. You have to know that semi means twice as often and weekly means 52. So if I took 52 and I times it by 2, I would get 104. And that's what I'm going to put down here as the number of times per year. To the power of 104 times. Now here's where this gets different than the ones before. How many times did we do this? How many years are we doing this for? We don't know. That's what we're trying to figure out. How long does it take? So I'm going to leave that as a T. So there's not really a great way to do this. You kind of have to do guess and check. But I want to write one note that I want you to remember. T must be accurate to 2 decimals. So we're going to play guess and check on our calculator. And I want we could get as specific as we want to be, but I want you to get specific to at least 2 decimal, to exactly 2 decimal places, no more, no less. So what I mean by that, so I'm going to have 1,000 times 1 plus 0.0635. Oops, I forgot to do the divide by. And I'm going to use fancy this time. 1,000, 1 plus alpha F1, 0.0635 over 104 to the 104 times. And then here you just take a guess. We don't know what time is. I want the smallest 2-digit answer that gets me to 2,000. So I'm going to say, let's say 10 years. How long does that take? Ooh, that got me pretty close. I'm at 1,800. Now I'm going to try to turn that to 11 years. Second, enter. I'm going to change this to 11 years and see how close I am. Oh, that's too big. I want to be the first number that's over. So it's going to be 10 point something. So second, enter. 10 point what? I don't know, 10.5, let's say. That's too low. 10.6. Too low. 10.8. Too low. 10.9. Too low. So now I know it's between, because we already did 11 and 11 was too high. it has to be between 10.9 and 11. So now this is what I'm talking about when I'm saying this second decimal point. 10.9, let's try 5. Ooh, that's over. So I know it has to be something smaller than 10.95. Let's try 10.93. That's over. So I've got to check 10.92. That's over. And then I'm going to try 10.91 to see if that's over. No. So I want the first answer that gets me over the amount that they wanted. Notice when I did 10.92, I got 2,000 point. Now, it doesn't matter how close it is. I want the first one that gets you over the hump. So 10.91 got me to 1998. 10.92 got me to 2,000. So that's going to be the one I'm going to write down as my answer. T, the number of years should be approximately 10.92 years. All right, you try the next one. See if you can figure. Oh, I got to be, yeah, you try the next one. All right, let's see how you did. So I'm going to take 30,000. I want to get to 110,000. I'm getting 10% bi-quarterly. So I'm going to end up with 110,000. I began with 30,000. It's always 1 plus. My percentage rate is 10%, so that's going to become 0.10 over bi-quarterly. So bi is half as often. Quarterly is 4. So for us, bi-quarterly would be 2. To the power of 2 times, we don't know, t. So this is a guess and check game. There is a way to solve this using logs. We haven't learned how to do that yet. So I want to find the first number that gets me over the hump of 11,000. Sorry, 110,000. So 30,000 times, I won't be fancy this time. I won't be fancy. 1 plus 0.10 divided by 2, close it, to the power of 2 times, I don't know, let's say 10 again. Nope, not even close. That's 79,000. I need to be 110. So second enter, let's try 20. Good. So that helped me notice that it's between 10 and 20. So now you just kind of narrow things down. Let's try 15. 15 is too big as well. Let's try 13. 13 is too low. Good. So now it's between 13 and 15. Let's see what 14 looks like. Okay, that's too big. So now it's between 13 and 14. So now I'm going to go 13 point something. I don't know what. That's too big. 0.5 was too big. 0.2 was too small. 0.3 was too small. 0.4 was too big. So it's somewhere between 13.3 and 13.4. So I'm going to go now. You remember, you need 3 decimal places. Sorry, 2 decimal places. I said that wrong. So 0.3, let's try 5. That's over the hump. Let's try 3.2. Oh boy, that's just barely over. I bet you that's it. But let's try the one right above it. 3.33. Yeah, that's, oh, wait, let's try the one right below it. I know that, I don't want to go to 3. I want to try 3.1. That's too low. See, it's not up to 110 yet. So that was 13.31 was at 109. 13.32 was at 110 and $53. That's the one that I want, the one that gets me over the $110,000. So my time would be, the number of years I would need is approximately 13.32 years. All right. So there's what happens when you're compounded a certain number of times per year. Another way we could calculate compound interest is compounding infinitely times per year. So yet again, we have the final amount A, we have the principal amount P, we have the interest rate, we have the number of years, but instead of N would essentially be infinity. It turns out you get a whole new equation when you do this. E to the R ends up being exactly as 1 plus R to the R over N to the N. Now, E is a number. It's not a variable. E is right here above natural log. So when I hit second, E to the, it always gives you to the. You can't avoid it. In E to the first, so E to the is a lot like pi. Pi is 3.14, blah, blah, blah. E to the first is 2.718, blah, 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 blah. So E is another one of our famous constants. Euler's number, actually. It's named after my favorite mathematician, Euler. All right, so let's take a look. So I've got the formula. Yet again, you don't have to memorize it. You just have to know how to use it. So we got $614 earned 6.6.5% compounded continuously. So that's 6.5%. I need to move the decimal 2 times, so that's 0.65. So my initial amount is 614. 614 times 614 e to the. Now my rate we just figured out was 0.065 times, and then time is for 6 years. So ignore all of that. Calculator at this point, 614. Second natural log is e to the 0.065 times 6 should be $906.87. Don't be the kid that rounds wrong and loses half a point. Round properly. All right, you try the next one. You could probably do a lot of the next ones, but let's see. See how you did. All right, so I'm going to just jump to the formula. 15,500. All right, sorry. I should have done this last time. As soon as you see the word continuously, compounded continuously, game over. You know you're using the PERT equation. If you don't see the word continuously, like compounded quarterly, compounded monthly, compounded semi-weekly, then we're using this formula. As soon as you see the word continuously, we're definitely going to use the PERT equation. To the, that'd be 5.75 moved over 2 times, times 8 years, 15,500 e to the 0.0575 times 8, 24,000, blah, blah, blah. 24,553 and 15 cents, rounded properly. So just like we did over here, where we worked in reverse, where I had to figure out the number, I gave you the end amount and you had to figure out the number of years. We're going to do the same here. So how long does it take to triple your money at a rate of 8.5% compounded continuously? Now this one's a little sneaky the way they wrote it, because how long, or what's our beginning amount, I should say. We don't know. They didn't tell us. They didn't tell us what the beginning amount is. That's okay. We can still answer this. All it says is you need to triple your money. And what's interesting about this, and why rich people seems to get richer faster, is so if I have $1 and you have $1 million, it's going to take us the exact same amount of time to take that money and triple it. So when I take my $1 and turn it into $3, is the same length it would take you to take your $1 million and turn it into $3 million. So it doesn't matter what you start with. If you need to triple your money, you can start with any amount that you want. You could pick $1, you could pick $10, you can pick whatever you want. I'm going to usually pick $1. So if I want to pick $1 and I need to triple it, how much money should I have at the end? Should have 3. I'm starting with $1. I'm compounded continuously. So that's going to be e to the, my percentage, 8.5 times time. So now we play the guess and check game again. This time I'm taking $1, e to the 0.085 times, I don't know, 10 years? Nope, not enough. I need to get to $3, remember? 20 years, way too much. 15 years, too much. 12 years, too little. 13 years, here we go. So it's between 12 years and 13. 13's too big. I got to go 2 decimal places. That's just me being picky. So I'm going to go 12.5, too little. 12.7, too little. 12.9. Oh, that's good news, because now it's between 12.9 and 3. So 12.9, I don't know, 5. That's over the top. 9.3 is still over $3. Let's try 9.2. Nope. So there's my number. 12.93 is the first number that has 2 decimal places that gets me over the $3 number. So my answer would be 12.93 years. 12.93 years. All right, let's see. Try the last one on your own. I'll go back over here. I don't want these to be for next year. I don't want them to say t equals. I just want them to have the answer. All right, let's see how you did in that last one. So how long will it take to quadruple your money? This time I'm going to say I've got $10. So if I need to quadruple, that means I'm getting 40 at the end, compounded continuously. So that's e to the, move the decimal point twice, 0.15 times t. Now we play the guess and check game. So I need to turn 10 into $40. So I want the smallest 2-digit number that gets me past the 40. 44, oh, that's good. Let's try 9. Great, so it's between 9 and 10. 9.5, too big. 9.3, too big. 9.2, too small. So it's between 9.2 and 9.3. 9.25, too big. 2.3, too small. So it's between 9.23 and 9.25. So let's see, 9.24. Too small, so that's it. So 9.25 was over. So 9.25 is the first one that takes me over into the 40 number. 9.25 years. All right, folks, go get them.